Hey everyone. In this video, I'm going to talk through steps I took to get HDMI output working on my Zinc 7000 based development board in PetaLinux, and specifically PetaLinux 2024.2. And I'm doing this from the ground up. I'm not using any board support packages or anything like that. And this is a custom board. Now, with that said, the HDMI circuit is very similar, if not identical, to what you would find on a Digilent RD Z7 or a Zibo Z7. So you're going to see that if you have one of those boards, I think the information in this video will apply and hopefully will be helpful. So I might start by just talking about what's on the screen here. This is my board in the lower right. It's currently sitting in front of me, and so I'm just waving across it. But this is the board that I have running, and in the background is the current output of its HDMI. So I had just booted it up, and you're seeing it sitting at a login screen. Now, a couple of notes. The HDMI output I have going into a little capture device on my Linux machine that I'm running right now. So that's where that background is coming from, though. It's the actual HDMI output. So it's not a serial console or anything. And then the picture of the board is just coming off of an inexpensive little webcam that I have positioned above it. So that's what I'm going to be working on and talking through in this video is how do I get that board up and running to output HDMI with, I've got keyboard support, and basically I can, at this point, fully log into. So if I want to come in here and type in, let's see, I think I log in as PetaLinux, forced me to change my password, and now I can work in this system. For example, I can go test the network functionality and say, okay, I want to ping digilent.com, and that's working fine. I'll break out of that. But that is me using my keyboard to interface with my FPGA, the Zinc 7000, and the output coming out of HDMI. Now, the reason I'm putting this video together is I found it difficult to find good information on getting this up and running. There are some walkthroughs, there's some demos, there's different things I could find, but they're all for older versions of PetaLinux and the Linux kernel, and just didn't seem to be working as I was going through them. So I had to kind of figure out what am I missing. And I'm going to do my best in this video to talk through what are those things that I did. I'm probably going to miss something as I go through this because there was a lot of trial and error. But if you have any questions or suggestions, drop a note in the video below, the video comments, and I can try to work on sharing some updated information in the future. Maybe what I will do is flip over to my desktop. And so I'm just running Ubuntu here. And I have a document that I'm going to pull up. Let's see if I can find it. This one right here. So I put this document together yesterday. And I did post this up on one of the Digilent forums where I had started a thread asking for tips or tricks or information on getting this to work. And since I got it working, I did post kind of a follow-up document. So I'll scroll through this throughout this video. So this video will probably complement the document hopefully pretty well, and vice versa. But let me maybe scroll through this and just talk through a few of these pieces. So again, my goal is to get HDMI output working, and I'm going to start out here with what is my development environment. So the machine I'm on right now is my development system for this PetaLinux, and it's an Intel Core i7, 14700F, 32 gig of RAM. I'm running Ubuntu Desktop 24.04.1 long-term support, bare metal. This is not in a virtual machine or anything like that. My previous videos, if you've been following, I've been using a virtual machine, and I kind of got fed up with it. Just too many miscellaneous issues with the virtualization, and performance just wasn't adequate. So I grabbed a new machine just for the sole purpose of running Linux, and this is for me a pretty quick machine. So that's what I'm running on, is what you see here. Now on top of that, I've installed Vivado 2024.2. That includes Vitis and all the other Xilinx or AMD tools. And then I've installed the PetaLinux 2024.2 tools. I'll go into more detail on that in a little bit. And I also grabbed a couple of source files from Digilent's GitHub. There's one for this clock, and then there's another for their HDMI output. And these are two specific files. I believe at least the HDMI one is needed, and possibly the clock is needed, but I will show you how to install both of those. Now on the operating system here, I've got down notes of what I did to install all of this. So where to download Ubuntu and Vivado, and again, I'll make this this document available in my GitHub. I'll put a link to that in the video comments below. I then did go through installing the PetaLinux required packages. There's some prereqs, and so there's a link, a file you download, and you run that. I had a couple of the things not automatically install for different reasons, but go through the output of that, make sure you ultimately install all the packages that script is trying to install. I then downloaded the PetaLinux tools, the 2024.2, and that is the latest as of this video. So I downloaded that and installed it, and I had installed it. I can just show you in my file system here. Just right in my home, I created a PetaLinux 2024.2. And so this is the installation folder that I'll be using as I talk through all of this. Then I can come over here, and after I did that, I did have to change the shell to bash, and there's a link here on how to do that, but basically this command here is what I use to change that. And then there are some errors you will run into unless you run, I think there's a couple different fixes, and I don't know all the details of this, but I put a link here on an article I'd found. And I just went into a script file that you run as soon as you want to start developing in PetaLinux. You source it right away, and I'll show that later. But I just updated that script and added in these two lines, and that'll take care of some errors that you might otherwise get later in the process. That's maybe getting up and running just with the tool set. So that gets me my Ubuntu Linux, that gets me my PetaLinux, the tool set so that I can start developing. And then that gets me into the actual development workflow. So maybe I'll take a look at a couple of things here. I mentioned that, I built my own custom board. So maybe let me just for a minute jump out and look at that. So I'm using EasyEDA Pro. I know that is probably not very traditional or expected for this type of a board. I've had a lot of people comment that why are you using this tool versus some professional tool? And I'll tell you, I would love to use professional tools, but as I've looked into them, they're just too expensive for me. I do this just as a hobby. So that's all this is a hobby, and I can't afford to spend hundreds of dollars a month on licensing for some of the better tools. But honestly, EasyEDA Pro has worked perfectly fine for me. So I'll give it credit for that. I've been able to do an 8-layer board here. And so my board is an 8-layer. I mentioned the stack up here. But basically, I'm using an XC7Z020. So this is the Zinc 7000 I'm using. And for this video, I think the only things I'll point out is HDMI is coming up here. And so this is the HDMI output right up here. And so I've actually got it mounted bottom side. That was just to make routing simpler. And then I also have an SD card over here. So this little micro SD card is what I'm going to boot up to. So everything I create in PetaLinux will basically plug in to that be placed onto that SD card that will be plugged in here. I also have a USB connection here. This is a USB AB connector. What is it? A mini AB. And that's where I can plug in a USB hub, a keyboard, probably a mouse at some point, flash storage like a thumb drive. But right now, what I have in this video, I've just got a Dell keyboard plugged into it. But I've experimented. I can plug in a full USB hub and then the keyboard into the hub, and everything's working there just fine. This here, it's not rendering it here, but I'm not sure why, but there is an RJ45 connector here. And that would give me my Ethernet connection. I have a little USB-C connector here that goes to my Linux system just for serial output and also to program, but I'm not using that programming as I'm using the SD card. And then a DC barrel connector for power. And then I've got some switches to change my boot mode, and I've got mine set to boot to the SD card instead of to flash on the backside or something else. So that's the board I'm going to be working with. And let me go show you the circuit real quick for the HDMI output. Because this, if you are working with a different board, like a Digilent board, you'll want to pay attention to what signals are being used. And in my case, I can go over and look at the Zinc 7000, bank 34 and bank 35. And on bank 35 is where I have really the bulk of the transmit signals for the HDMI. And bank 34, in the future, I do have it set up that I can also bring in through a different connector HDMI, but I haven't gotten to that point yet. But I also do have an HDMI signal up here. So there's one signal up here, there's a bunch over here. And then this, of course, is showing me which ball on the BGA, or which pin, however you want to say it, that signal is connecting to, which will be important when I get to my constraints in Vivado. If I go over to the HDMI, then it's just a connector, so just a simple connector. These are signals coming from the FPGA or the Zinc, some pull-ups, and then I've got this little chip here that's just helping to do power and we filter out spikes and things like that. But this is a little TPD 12S016, so not a big deal. But this is the basic circuit that's coming this side from the Zinc 7000, getting me to my connection that I'm actually plugging in my HDMI connector. Okay, so that's enough on that. I'm going to get out of that and then say, okay, I've got that hardware to work with. Now I need to get in here and start working with Vivado. I think I have Vivado running here already, so I'll pull that up. This is an old project, and so if you see some of the naming on this project, like it says 16-bit processor or whatever, don't worry about that. All I want to point out here is this block diagram that I'm using to configure the hardware prior to going into PetaLinux. Now, a little background, a couple of years ago, I used an RD, so a Digilent RD Z7, and I built an 8-bit processor on it within VHDL. So basically like Ben Eater's video series, if you're familiar with that, he builds an 8-bit processor, basically module by module or piece by piece on breadboard. I basically did that same thing, but then I did it in VHDL. So I've got a bunch of that, but at the end of that, I wanted to output something that showed it running. So I had an HDMI output that just showed this 8-bit processor running and the status of the different registers and buses and all of that stuff. Fun little project. But in this case, I wanted to just come back to that HDMI output and see if I could use that in Vivado. So I went into my design here. I deleted everything that had to do with the 8-bit processor, and I left just the video stuff. Now, this video setup initially started from the Digilent RD Z7 HDMI demo. So they have a demo, they have a starter that you can open up, and most of this is quite similar. I've probably modified it a little bit. And in this document over here, I go through this, I capture it in the document to say, okay, let's talk about how did I set up my constraints. So I come into my sources and I come down to my constraints. And for me, these are the constraints I'm using. So this is just setting up my HDMI data and the I2C connection, things like that. And I'm telling it which connection on that Zinc 7000 chip, which, BGA pin, is it using. So if you're using something different, like a Digilent board, of course you need to make this match. And so you would go look up Digilent. Digilent would supply the constraint file that you should be able to use. And even if you look at their examples for HDMI output, you should have all of that already ready. But I had to change that because my pinout maybe isn't the same because I'm using a different chip than the exact ones that they're using Digilent. But I set that up, and that's what mine looks like there. And then I come back to the diagram, and there's a bunch of stuff in here that maybe isn't super important. If you go get the sample from Digilent again for the RDA7 HDMI output, or the Zibo, I think you would get something similar here. But maybe I'll zoom into, off to the left, there is the actual Zinc processing system. And then what I am using is I'm using this AXI Dyne clock, which is a dynamic clock generator. I'm using an AXI video direct memory access. I'm using a video timing controller, an AXI for stream to video out, this RGB to DVI, and it's labeled RGB to DVI video encoder. And I can see that some of these say pre-production. I think somewhere on here, maybe, yeah, like here, this one down here, there's some of this that's discontinued. So maybe there's some better ways to do this, but this is what I had from a couple of years ago, and so this is what I started with. And that's one of the things as I was troubleshooting. I did a lot of bouncing back and forth between the Digilent examples that they have and how they've configured all of this, and my specific board, and then the configuration inside of PetaLinux. So I have to be really precise on all of that. Things to maybe point out on the processing system, the I2C, this IIC0, is being used for one of the signals that I'm using for the HDMI. And I can go in and look at this and see that that would be this, this one down here, I2C0. So in my case, I have to pay attention to that because on some of the demos, they're using the second one, the I2C1. So in my case, my I2C is 0. I can scroll to the right and see that that's through EMIO. So that's an important detail as I get into this. I think as I get into some of these other pieces, I'll just show you how I have these configured currently, which doesn't exactly match some of the demos I've seen. So in my case, at least, I'm using 3 frame buffers. I think some of the samples I saw showed 4, and some of these values are different through some that I've been looking through, but this is what I'm using. I put all of this in the document, all of these I did screen caps on so you can see what I'm using. May not be optimized or ideal, but that at least you know what I'm using to get the output. So I don't think I'll go through, I'll just flash these up real quickly in case you want to pause and look at any of them. But 720p output. This converter down here that has a lot of detail in it, so you can take a look at this, how I've got that set up, just to make sure it matches if you are trying to get this up and running. I have a GPO input over here to the far right. This is a signal that comes from the LCD screen, from the HDMI device, basically back in to say that the cable's plugged in, is my understanding. And that's probably good enough for now. So this is the main block design that I'm using based on my specific hardware. And then from there, I would come down here and I would hit generate bit stream, and that would generate a bit stream. From there, I would do a file and I'd say export, and I'd export hardware. I think on some of the projects, depending on if it was a newer project, it might say export platform instead of export hardware, but pretty much comparable. And then I would come in here and I would include the bit stream, and I would save that file basically, and call it whatever I want to call it. So that gets me my hardware file coming out of Vivado. So then what I can do is I can move on to getting into PetaLinux. And if I come back over here, then in this document, I go through, again, talking a bit about the block design. I mentioned in Appendix A, I've got all those print screens. So if I fly down to the bottom of this, you'll see that in this section right here, you can see I've got all those print screens if you want to browse through those and just kind of get a feel for my setup. And I did put in also at the very bottom, you can see the basic schematic information relevant to this from my board. And if anybody wants the full board schematics, I'll be posting those too on my GitHub sometime in the coming week. Okay, so if I continue on, I had to make sure that in Vivado I had my constraints set up. I got the block design tweaked, and that was iterative. You know, I was doing some trial and error, changing some things, but ultimately got that to work. I created my export. I did my export hardware with the bitstream, and then it's to get into PetaLinux and start working in that. And I can just show you that. I'll walk through some of this kind of more live as I go here. But I installed PetaLinux again into home in my PetaLinux 2024 folder. And I have this one right here is the main project that I'm working on. I had also brought in an old Zevo Z7 project from Digilent, and that was helpful. I wasn't trying to build it, but I did bring it in here so that I could go through and compare, for example, settings inside of this meta user folder. There's a lot of settings around kernel or configuration, and that was helpful to come in here and just compare and see what did they have. And this would have been years ago, back on the version 2021.1 or 2021.2, something like that, PetaLinux. But I could at least compare, and that was helpful for me to see what I was missing in mine. But I'll be working in this one here, this REHSD Zinc. Now, first I need to run the settings file, though. That's what's over here, this to the right. And so what I typically do is I just come into this folder and I open it in a terminal. And then I can say source and point to that settings file. And that runs their script. And then I also had those two additional lines about this AppArmor, so those run. Now at that point, I can start doing my PetaLinux work within this window here. So then I need to create a new PetaLinux project. And to do that, in the documentation here that I put together, I just said, okay, you use this command, PetaLinux. So I'd come over here and say PetaLinux, and I do a create. I want to create a project. I point to it as a Zinc template because I'm using the Zinc. And then I'd give it a name. And in this case, I had called mine this name here. And I'm not actually going to run that, but that'd be the command that I would run that then creates that folder that I can now get into and see what's inside of there. And I can pull that up visually here too, so you can see that. I do have some backup zip files, so as I was making progress, I like to back up my configuration, and I also copy it off of this device just in case I manage to lose them or lose the configuration on this device. I've got it backed up. I would say PetaLinux is a slow, tedious process, and if you don't have a fast machine, it's even more painful. So get a fast machine if you're going to be working on this, is my recommendation. And then you're going to have a lot of starting something and then waiting a couple of minutes before it finishes, time to grab a coffee or whatever. So since it's such a slow process, if I get things working, I definitely want them backed up. So that's what I've been doing here. But one of the things you'll notice here is this XSA. So that would be the output, the hardware really definition that I exported from Vivado. So I just copy that over here. So I was in Vivado over here. I did the export hardware. That file, just want to get copied into my folder for my project. I think you can put it in other spots. That's just where I happen to put it. And so in the documentation here, I just mentioned, okay, create the project, and then a couple of important things. You need to create, I think there's two ways to do this, but you need to get at least the, let's see if I've got the right ones in here. That might be wrong. Double check something. Yeah, that is incorrect actually. So I'll put just a little blurb up on top of this in the video. But you need to create one for this clock, Digilent Dyne clock, but then there's a second one, and it is Digilent HDMI. It is not the Digilent encoder. So this PDF is incorrect, and I will need to get that updated, and I'm going to make a note here. But you'll run this command here for sure, and then the second one, instead of saying Digilent encoder, you're going to want to say Digilent-HDMI. Okay, and I also noticed that my numbering for some reason skipped 5 and 6. I just fixed that in the source doc. Okay, so then moving on from that, if I had come over here and I had done my, again, PetaLinux, create modules, and then I say I need to create these specific names, like so, and I'd run that, and then I would follow that up with the second one, which would be Digilent-HDMI. So these lines are basically setting up modules that will get loaded outside of the kernel to support a couple of these drivers from Digilent. And again, got the clock driver, and then HDMI is what it should be. So I'll get that document updated. And later, we'll fill in the contents of those files. So then I need to import hardware. And there's a command to do that. So I basically come in here and I can run this command right here, and I can actually go do that. So if I come over here, and I'll just paste that in and run that. And so this says no such directory. And that's because I had used, let's see, this would have been an older version. And I changed the folder from PetaLinux to PetaLinux 2024. I can type. Okay. And then that imports that and brings me into this configuration. Now, these, oh, there's a lot in these, and there's one for this config. There's one later for the kernel, for the U-boot, the root file system. And as I go into each of these, then it's knowing, well, what do I need to change in a lot of these? Now, Phil's lab, he's got a video where he goes through, he's got a couple of videos where he goes through getting PetaLinux up and running, and he flips through some of these. What I did, two things I would point out is, one, I had in my documentation here just listed the things that I believe I had set. And so you can see that I can scroll through here, and there's a whole list of things that I probably want to make sure are set. And some of these are, well, most of these are set by default, and then some of these are maybe are explicit changes I made, like this, all of this, picking the system, that's all going to be there by default. But maybe on the Ethernet, there are some things and I don't think I even changed the Ethernet settings. It's on DHCP, partition information, boot args. So most of this is going to be what you're going to have just out of the gate without having to do anything. And I'm just scanning to see if there's anything that I would call out as more critical. but not a whole lot there. I think maybe if I come here, page packaging options, I turned off this one that says copy final images to TFTP because I'm not using that. But if you want to double check any of these, and at first I didn't even notice this was a feature, there's a slash to do a search. So you can just do a slash and you can type in, well, what are you looking for? So maybe there's something about, I don't know, I'll just come up here. There's one of these. Maybe I want to go see, do I have that one set? So maybe I want to check this one here. I'll just type in then QSPI boot SCR size, and that'll then search for it and will show me how it's set, I believe is what's in the square brackets up here. So it's currently on auto. I want to go grab a different one. Maybe I come up here and I say I want to double check. Is this config system zinc set? I'll just do a slash and then I'll type, you can skip the config underscore, but just system underscore zinc. And that comes back. It tells me where it's at. As I look at this, some of these are more helpful than others, but then it also tells me how it's set right now. So, okay, yep, that's a yes. I can then say I'm good to go on that one. But I tried to capture how I have currently configured my system in case there's something in here that catches your eye or you're comparing to your configuration. Then I mentioned that, okay, within, maybe this is where some of my numbering got messed up. I think I had inserted a section that messed this up. Within the project folder, I mentioned to copy the contents of these encoder files. There's the digital encoder. And again, I've got the wrong one listed there. So I'm going to correct that on the document. Okay, I just updated that doc. I'm going to actually close this one. Go grab updated one quick. Because those errors there are going to be confusing. Okay, so let me get back down to development workflow and then creating the modules, and then within the project folder you can go out and copy the content. So I updated this to correctly say Digilent HDMI, and basically what you're going to do is after you run these two commands to create those modules within your project, so in my case this one here, I can go into this project spec, meta user, and recipes modules, and it will have created these two folders for you. And each of these folders then, I can go into this file subfolder and I can look at they'll have a template here, but what you're going to do is download that file from Digilent, from their GitHub, and you're going to paste it in. And so like right now, this is the one that says it's a Digilent FPGA HDMI driver. And I did at the top of the document here list a link to that location. So if I hit this, I can see all the content there, and then I have specific links to the correct two files. So what you'll want to do is copy the contents of these over into their associated file over here. So copy the contents of the HDMI into this one. And if I go back up, same thing for the clock. And you can see that if I get in here, these are not the template ones that will be there when you first create those modules, but these are ones that I had pulled from Digilent. Okay, so I reordered this document a little bit, so it's okay, create the modules and then put in the contents of those files based on what is coming from Digilent. Okay, so then if I continue on, I mentioned to do some importing hardware, and I can see the formatting of this document still messed up, so I've got some more work to do just with getting some of these sub-bullets ordered correctly. Why they're continuing, I'm not sure, so I'll come back to that, so just ignore that. You'll find a cleaned up version get posted. But I then mentioned that, okay, this hardware description, and if I come back over here, that's what was done before, so I'm good on that. And then I had talked about these were the things I had used for settings, so I've already covered all of that. Okay, so let me keep going and get into this next section. So then updating the device tree, there is a file, and if I go back into, again, here's my folder for my project, and I can go into project spec, be in here often, and meta user, be in here often. And there are these recipe folders, and there's one for BSP, board support package, I suppose is what that's short for, and device tree and files, and then I can open up this DTSI file. And this is a really important file that you'll have to pay a lot of attention to in the settings inside of it, because if they're off a little bit, things don't seem to work. So, but I did paste in here what I have, what I've used in this file, I guess. And so if I just scroll through this, I did have some stuff that didn't work as I would think it should, like this include file, but ends up I don't think it's needed for this file, and I went without it. Coming in here, then I just say, well, here's the model of my board. I put in some labels to say what kind of compatibility, and I'm pretty sure the Xilinx Zinc 7000 needs to be there, and then I just made up this one. I don't know if that's good or bad, but I made that up. Got some boot args. This is my USB PHY configuration that I put in there, and that's not so important for the HDMI output. I've got this gem for my Ethernet. Most of this doesn't matter until you get to here. So the I2C, I need to make sure that matches. And back when I was in Vivado, I had pointed out that I was using the I2C 0. And so I need to make sure this is I2C 0. I have a clock frequency, and I have to say status is okay. And then there's this, I don't know, programmable logic section. And I don't know exactly what AMBA stands for, but there's this section that you have to have these sections for digital and HDMI, and also this Xilinx programmable logic display. So I've got those sections in there, and this is what I have for settings. And these are commented out, so you can ignore those, but pay attention to everything else. So this is pointing to where my clock is, which I further have information on down here. It's pointing to my I2C as I2C 0 is being used. And then I come down here to the display, and I'm pointing to a very specific DMA. This is a VDMA 0. And again, I can go back to Vivado and look at the names, and it has to match that. And then I'm using V format. I think I had seen one post that there's different things you can try there, but right now I'm using RG24. Later, when I get into testing colors and stuff, I'll have to see if there's also an RGB 888 that I want to try. And I think that maybe is what I should be using, but right now it's at RG24. Just slight variation in how colors are being handled in the data. So I guess I haven't done anything color-wise yet on my output. So maybe later when I go look at something that is color, I'll see that my colors are wrong, and then this is where I would first come and double check and see what's going on. This bridge, this has to match again what's inside of my way back over here, like a VTC 0, and that's right up here, VTC 0. AXI dyne clock 0, AXI VDMA 0. Those are what I'm trying to match all of these to. A little bit about the DMA range, a little information about the clock setup. And then this VTC, same thing. I've got a couple of comment lines. You can ignore those, but it's really just this is what is being said in there. And then I have a commented out VDMA, so I guess I could delete that. There's no point in that. Let's see, AXI VDMA 0. This is commented out, so I can just actually delete that if I want. And then this GPO, AXI GPO HDMI. Again, going back here, I'd want to find, and that would be this one right here, AXI, GPO, GPIO, HDMI. So I need to match those names. So if you're looking at your block design, those names are really important, and then you need to make sure you're matching up to what you have in here inside of this DTSI file. But hopefully you're seeing these are the sections I have, these are the values I have in there. You can reference the names I have in here versus the names I have back in my block diagram. Okay, so you go through and you do all of that, and then you need to configure the kernel. And so that would be coming over here, and I can do a PetaLinux, and do a config, and then kernel. And this is where on a slower machine, this will sit and grind for a couple of minutes before you even get to the configuration tool. And then when you leave the configuration tool, it'll sit and grind for a couple more minutes, or maybe longer, I don't know. But I know going to this pretty quick system I'm on has made a world of a difference. But once I get in there, it's similar to that previous configuration utility that I had up. I need to go through and just make sure all of these things are set. And up top right away, there's some that I think are probably important, like configure I2C Xilinx. I'm going to assume that's important. It could be that some of these are unnecessary, and if I did a whole bunch of trial and error, I could figure out which ones I don't need, or if I could find the right documentation to help me understand which ones are needed or not. But these are the ones I have, and I know that this configuration is working. So now here I'm back into this screen, and this is now says kernel configuration instead of that general configuration I was in before. And same thing, I can now say, well, okay, do I have this DRM Xilinx bridge enabled? So I could do a slash, and I would do a DRM Xilinx bridge. And this shows me there maybe are a few things that match that. There's a bridge CSC, a bridge debug FS, and I can scroll down and there's some others. But for what I'm looking for, it's this one here, and it is enabled. If it was not enabled, it then says this is how you get to it. So you'd have to go to device drivers, graphics support, Xilinx. And so I would exit out of that. I'd go into that path that they pointed to. So device drivers. Oops, I accidentally exited out. Quirky tool, and I'll come back in and show you what just happened there. But basically, on the bottom of the menu, there's a select or an exit or help or another option. And even if you're arrowing up and down above, the bottom selection is what takes. And I don't know, it's just quirkiness. But let me get back to that. So again, I have to wait for this, and I'll get back into that momentarily. But while it's doing that, you can see I've got a lot of stuff that is set. Much of this, again, is probably default, but in case you want to compare your setup with what's working for me, you can go through this list and see if you have all these same things selected. Now, I do believe there were some that didn't show up in this tool for me. And like this might be one of them, this common clock, Digilant dying clock. So if that's the case, I believe you can just go out, this is what I did, you can go out to this file, this BSP file, and just manually add it. So keep that in mind. If you're not finding, and it should just be the Digilant ones, I think all the other ones will show up in here, but for some of these that did not show up, and I think you can modify that kconfig tool or whatever it's called to have those things show up, but they're not showing up. I just went over here and manually added it to this BSP file. And so maybe while I'm waiting for this other thing to pull back up, I could go in and say, let's go to meta user recipes, kernel, Linux Xilinx, and then I've got a BSP, and you could just paste it in there. And like you can see, that's what I did right here. I just have it pasted in there. Okay, back to this. What I was pointing out earlier, I accidentally got out, is see at the bottom, if I tab over, anything I do up above, if I press enter, it still takes me out because down below it's selected exit. So you got to tab to make sure you're on select. But then if I wanted to, I could go into device drivers and then find, which one am I looking for? And you can see there's a lot of stuff in here. And I'm sure in time you'll kind of remember where everything's at. But for me, that search was super helpful. But like previously, it told me to go to graphics support, and then I could go through this and make sure I have the right things selected in this list, like this Xilinx DRM and the bridge and programmable logic display driver and a VTC driver. But you get done with all those and you exit out of here and save on the way out. And that will get you through the configuration of the kernel. And then we have to go into the configure U-boot, and it's going to be the same drill. So it's the same, I think it's called kconfig, but whatever that utility is, when it comes up, the U-boot configuration, this is the command I'll run to do that. And then I did capture my settings, again, for your reference if you want to compare with what you have. But this is what I have on mine. And again, this is working with these selected in my U-boot. So I can come over here, I would do my PetaLinux, I do my config, and I would choose I want to config the U-boot. And once that comes up, I would then want to just search for all of these or go to them if I know where they're at, but check the values and make sure that these are enabled. And I don't know if there's anything if it's enabled that shouldn't be enabled if it'll cause you problems. But if you have something enabled that you don't have in this list, it's possible I don't have it enabled. But now here I'm in the U-boot configuration, and again I can go through and for example, update my networking support, and I actually need to come back and probably add more stuff into this as I continue, but that's what I had as of right now. After that, repeat the process for rootfs. So you'll do a config, and then I listed out these are the things that I have in that. And again, I've got a couple. I'll show you these here. If you had created those modules, and I come into this, they should show up under user packages. And so now you see I created the modules, I copied over the code from Digilent into the contents, but now in this configure rootfs, those will show up and you want those selected. So the clock and the HDMI one from Digilent. And then any other settings you might see in here that you're like, okay, I don't have those enabled, you'll want to consider enabling, but I will get out of that. At that point, you do a build. So I will do a PetaLinux build. And again, this can take quite a while if you aren't on a pretty fast machine. So even on this machine, which I'd say is a pretty quick processor, this will grind for a while. And if I go watch performance while it's doing that, probably see that there's points at which it's going to peg, especially when it's doing the compiling, it's going to peg my processor cores. But let this grind away. After that's done, I'll just step forward on some of this while we're waiting. I run this command here, and that basically grabs all the pieces and gets stuff ready for my basically my SD card. And so I want to get my files ready for that, and I can open up my current files, which will get updated when I run that. But what you're going to see is that I put it into my starred because I go there all the time. But it's going to be this location. So within my project images Linux, it's going to create all these files. And there's 3 of these that I need to copy. Let's see, it would be these 3 files I need to copy over to the first partition on my SD card, which needs to be a FAT32 type partition. And then in addition to that, I run this command, which will take one of the generated files called rootfs.ext4 and write it to my second partition on my SD card. And maybe while I'm waiting here, what I'll do is put an SD card into my SD card reader on this Linux machine. And now if I go back here, I can see I've got my smaller FAT partition, and then this one happens to be a 60-something gig for the rest of it. And these 3 files I'm copying manually. All of this content will get brought over as part of this this command here. So I'll get that done, and it looks like my build got done in the meantime. A warning message, no errors, and it built successfully, so that's awesome. And so then if I back up, I need to run this command. So I'm just going to paste that in. That is not the right one. What happened there? Let's try that again. Copy that. There we go. And it looks like that PDF doesn't let it copy quite right. Okay, and for this I need to be in the images Linux folder. And let me do that again. Okay, so now it did its work, and I can now copy over to that SD card. So I'm going to just run this command here. And then in addition to that, I need to manually, while it's doing its thing, I'm going to go back over to that, grab these 3 files, down to my boot, paste them, replace them. And so that now got me those 3 files, and now I can eject that SD card. So the SD card is ejected. I can now take it out, put it into the SD card slot on my FPGA board. And then at that point, it's making sure your device is set, and I've got this little set of dip switches on my board that let me choose where I'm going to boot from. The way I have it configured right now is to boot from the SD card over here. So I'd put that SD card in, I'd power on, and see what I get. So I think that is, the key walkthrough. The rest of this is just, again, reference for what I've been talking about. I do have a copy of this file, which is in project spec configs, and this shows me, some of the naming that is being used coming from my hardware. So that's kind of handy to look at. I also have copied in here what my boot process looks like. So maybe I can open up, I'll just open up another window here, and I'll open up PuTTY. Okay, and so here I've got PuTTY. I'm going to open up a serial connection to my USB 1, which is the line coming in to right here on the board. And that's my serial out. And let me just pull that over here. I'm going to reset this so you can kind of see it boot up. But basically now it's booting to the card I had in there. I didn't swap cards, but it's going through the boot process. And that boot process serial log data is what I put in this document. So I'll slide that over here. And I just put this in here because when I was going through trying to figure out, am I making progress, I didn't have anything to compare to what should I be looking for. And again, I'm not saying my output is exactly what is perfect or right, but I know it's working. And so here then, if I scroll down, I did highlight some lines that seem to be relevant to display stuff. So you can compare your output to what I'm seeing and see if you're getting those same things or something else, errors or anything along the way. but that gets me then all the way down to a login, and I have it set to auto login. That's one of the configurations I set up in PetaLinux. So there I'm now logged in, and through this console, I can change directories. I can do all the normal stuff I would want to do. So maybe I go into dev and I do a listing of what's in dev, etc. Other things I might do, let me flip over to a different view. And I'm going to go to this view, which is of the board along with the actual output. And I'm going to slide my main keyboard aside and grab the keyboard that's plugged into my FPGA board. But now I'll hit reset one more time. So I'm going to hit reset right now. And you'll see that as this comes up, what you'll get when it gets to the far enough on the initialization is a blinking cursor. So that's the first sign, and that was the first thing that caught my eye the first time I had this working. It's like, that's good. I've got a blinking cursor. And it's going through the normal boot, that you saw in that serial log, but then this is the next thing that comes up. And so then I can log in. I have to set a new password. But then the same thing. Now I'm in the system and I can do whatever I need to do within the system. And that's, again, running off of the SD card, I guess, content that was copied into RAM, running from RAM. The way I have it configured right now is every time I power off and bring it back up, it's kind of resetting back to its frozen state off of the SD card. You can change that, I believe, so that it runs off of the SD card and not off of a RAM drive. And that way you can persist any changes you've made while you're running it. So next time you boot it up, it picks up those changes that you previously had saved. But I think those are the highlights. And if I'm missing something, drop me a comment or a note. And I know I'm missing something, but I'll do a little bit more cleanup on that document. Any feedback I get from folks, I'll get put into that document. And like I said, I'll get this all posted to my GitHub. Hopefully you found this helpful, and I don't even know how long I've been talking, so we'll see how long this video is, but hopefully this has been worth your time and helpful. Thanks for watching.